All right, so let's continue what we started yesterday. So yesterday again, I finalized by emphasizing that factorization is all about finding the factors of a number or something. So if you know that that is what factorization means, then from here on it's just a matter of learning the various strategies that we can use to factor, but my emphasis now would be algebraically, using algebra or understanding algebra. So let's go. These are our objectives for today. Firstly, we need to be able to identify, and that is the number one killer. We need to identify and factorize using various expressions. Sorry, factorize various expressions using the HCF or the GCF method. And my emphatic word here would be identify. This is what has killed a lot of students. They don't know when to use which strategy. Some probably could rattle out all the strategies, but they do not know when each one can be used. So we're going to be putting major emphasis on this today. You also have to become aware of these guys, HCF and GCF. And this is one of the things CSEC tends to hold a lot of students with also, especially when you know all these strategies. And believe me, even from my own experience, when you know all of them, sometimes it's hard. I would not deny that. Sometimes it is hard to determine which one can work or which one to use. But that's the thing, it doesn't matter. Once you know all of them, then just apply them. If it cannot work, somehow we'll get blocked or stopped along the way. And that's all well and fine. That simply means that, okay, you have to use another strategy. And last but not least, you have to be able to prove your answers also. And this is the beauty about factorization. Just like if we have a number, in the last video we did the number 32. One of the proof that we have a factor of 32 is that based on whatever combination we make, we should get back 32. So I think we started with 2 and 16. And one of the things we could prove that these two are factors, of course, is if we multiply these two, we will get back our 32. Same thing applies when you're doing it algebraically. I will show you, however, how to do it, just in case you might want to prove your answer. Or in the event that you made it in a multiple choice, you would know for certain that what you did was right. So let's go. How can we tell that we should use the HCF or the GCF method? Okay, right away. So long as there is an expression with common factors in each term, the HCF or the GCF method can be employed. And this might sound complicated, but it's really straightforward. So if you get a question, for example, wild example, you see 2x, then you see 3x, and then you see 6x. Now let me just use 6 because 6 will incorporate the 2. You see 5x. If you are asked to factorize this is what I'm saying here. So long there is an expression with common factors in each term. This here is a term. This here is a term. This here is a term. So each one here is a term. And if you look carefully in each term here, you can see that there is a x, there is a x, there is a x. This is a perfect scenario where the HCF or the greatest GCF, I put GFC. This is supposed to be GCF, greatest common factor, not GFC. That's a mistake. Right. So the HCF or the GCF could work in this scenario or in this expression because each term has a common factor. And as we progress, you would see that the common factor doesn't just have to be the algebraic expression. It could have happened that the numbers, the numeric part of the expression, or I will call it coefficients for now, they could also have been common factors. For example, originally I was going to put a 6, but I took it out because I didn't want to put emphasis on that. But if we have a 6 here, between the 2, the 3, and the 6, there is a common factor, and that will be the number 2. Good? So that is something that you just need to be aware of, but I'll leave it at that. Let's go further. So examples and non-examples. Let's look at an example and a non-example. So here we have 12y and 4. This can use HCF because there will be a common factor between the 12 and the 4. 4 could go into 12 a certain amount of times, and in 12 there is 4. Over here you can see that there is no common factors. There is nothing that could go into 4 and 3, and there is nothing that could break down B and C. So this here can work. And that's what you look at. That is what you know. So for CXC, all you will see is factorize. That's all it will tell you. Factorize. But then you now have to determine, okay, factorize how? HCF, difference of two squares, completing the square, quadratic formula, that's on you. Moving on. Second one example, clearly, we could see W here, we could see W here. Here, yes, there is an X, yes, there is an X, but this term doesn't have an X. So we cannot factorize the X. This could be factorized, of course, but not with the HCF method. So this is a no-no. And last but not least, here we have 2, 14, 8, and 16. These are all common factors, or there is a common factor that could go into all of these, but the letters no. So of course you exclude the letters, but the numbers, you pay attention to that. Over here, again, there's nothing that could go, so yes, this is a check. But over here, no, nothing would work. Because we have 5, we have 12. And of course, there's no factor that could go between 5 and 12. And yes, here we have an X, but there is no X here. So this is a no-no. And that's basically how we go about identifying. So to use the HCF, in any factorization question, you just look at each term and see if there is something that can be factorized. And while we are at this, you have to bear in mind that we have these guides. So sometimes it may not come explicit, but you have to do something to get it to that stage. And hopefully in the future we will see more like this. So let's see. Let's do these two for an example. So here we have x cubed plus x. Clearly we could tell that the HCF here could work. Why? Because we have a common factor here and we have a common factor here. And I'll teach you this while we are at it. Whenever you're dealing with algebraic expression, the common factor of two algebraic expressions will always be the one with the lowest exponent, the lowest power. So here we have x to the 3 and here we have x to the 1. So you always take the exponent that has the lower degree power. So here the common factor between x cubed plus x would be x. So that's what we do. We put the x outside and then we open a bracket to factorize the remainder. So x could go into x cubed. I will use long division for this. No, I will expand it for you to see. So this is the same as x times x times x. This is x cubed, and that is divided by x. So 1x cancels 1x, and that will leave x times x, which is the same as x squared. I just did it that way so you don't understand what happened. Plus, if I do the same thing for x, remember this is the same as x divided by x. X could go into itself once, x could go into itself once, so we will have 1 here. And that is our answer. So if we factorize x cubed plus x, we will get x into x squared plus 1. And I did spoke about proving your answers. How do we prove our answers? We just have to distribute what we got. And by distribution, I mean we multiply the x by this and we multiply the x by that. And if we do that, we should end up with what we started with. I wouldn't go through that process, but I'm pretty sure that you could see. And that is how you prove that you factorize using the HCF the right way. Let's look at the second one. Here we have 12, we have a 6, we have a d cube, and we have a d. So right away with the d's, we said that, okay, d's come in here, d's come in here. So we take the d with the lowest degree power, which will be d. But 12 and 6 also have factorable numbers, or they are factors that are numeric. And in this case, the highest common factor between both of them would be 6. So with 6 and d, we factorize inside. So 6 will go into 12, we have 2 times, and d into d cubed would be d squared minus 1. And that's our answer right there. I trust you understand that. If not, of course, feel free to ask a question in the comment section. So remember, I divided the 6 by the 12, and I divided the d by the d cubed, and then I do the same thing on the other side. I divided the 6 by 6, and I divided the d by the d. And that's how I end up with what's in the bracket. Good. Right, so this is your turn now. Here I have 4 questions. This is where you could pause the video and attempt it. And of course, see if we have the same responses. I will not pause, however, I will move on. But you pause and give it a try. So I will. So for number 1 here, we could clearly see that the 9 is the common factor here, and 9 is common factor here. They have 2 things in common, and that's the 9. The algebraic expression, the x and the y have nothing in common, so we just leave those as they are. So here we just factor out the 9, and when we divide here by 9, we get x minus y. The 9 cancel out each other. And here we could clearly see, we could easily see, if we multiply 9 by x and if we multiply 9 by y, we will get back what we started there with. Good? This one kind of easy to see. Good. Let's try this one. Ooh, this one has some work in it. So first of all, let me look at the numbers first. 81, 27, 36. Yes, I could see a common factor in all of them. I could see 9 being able to go into all of them. And the 9, again, that comes with a little experience and understanding factor, but you might see a little trouble figuring out that 9. But if you are struggling to find 9, my advice to you, again, is just break down those numbers and find factors that from those numbers and see which one is the highest. Let me do that quickly. So, for example, I have 81. I know that 9 times 9 is 81, and then we have 3 times 3. Good? So these are all the prime factors of 81. Then I have 27. 27, I know we could get 3 times 9. And then 9 comes down to 3 times 3 again. And then for 36, we have 4 times 9. And then we have 3 times 3. And of course, over here, we could have 2 times 2. Right? But notice the highest common factor between these three numbers, the highest one will be 9. Yes? Notice 3 is also common between all these three numbers, right? Look at there's a 3 here, we have a 3 here, we have a 3 here. So 3 is also a common factor, but it is not the highest common factor. And that makes a difference, right? So we're looking for the highest common factor. So that's one way to go about it if you see some big numbers and you don't know which one is the highest common factor. Or of course, you could use your calculator, so you could easily figure out which number could divide into all these numbers as a highest common factor, right? Let the word highest be your keyword. It's actually the highest common factor. It's the highest number between the three numbers that could go into the three numbers. And in this case, it's actually 9. In another scenario, it could have been the 3. In another scenario, maybe it could have been the 2. You never know. It's based on the numbers, right? Good. Let's look at my A now. There is an A here, there is an A here, and there is an A here. So A is also a common factor, and this common factor, the lowest degree one will be A. Then I have B. B is here, no B here, no B here. C, no C here, no C here. And D, no D here, no D here. So these are all my common factors. The others are just extension, they just stay as they are. Now, how many times can 9 go into 81? We know. How many times can, yes, 9 could go into 81 9 times, and A will factor out A, so that will leave the first part here as 9B. Plus, just put back my addition sign. Then we have, how many times can 9 go into 27? We have 3. How many times can A go into A squared? That will be A times. And how many times? Well, the C just comes out. Nothing to cancel out the C, so we just bring it back as it is. And plus 9 into 36, we have 4. A into A cube, we have A squared. And nothing to deal with D, so the D just comes down like that. And that should be our answer. I trust you got that too. Moving on. Here now we're looking at these terms. So the 3 and the 33 definitely have something in common. And x definitely have something in common. So between the numbers, the lowest common multiple will be 3. And between the x's, remember we always say the one with the lowest exponents, the lowest power, which will be 3x. And then we open our bracket. So 3x could evidently go into 3x one time. And on the other side, 3 will go into 33 11 times. And 3 squared will go into x to the 5th x cubed times. So one way to look at it, x cubed. And again, whenever you're struggling to break down this, I remember, just expand. So x to the 5th is the same as x times x times x times x. 1, 2, 3, 4, 5. and you divide that by x squared, which was x times x. So x cancels x cancels x, and that leaves us with 1, 2, 3x. So that's how I go about doing it. Over here now, I'm looking for the common factors, and I could see here that the common factor between the numbers will be 4, and the t doesn't appear across the board, so then t is not a common factor, so it stays just like that. So we just open out with 4. 4 could go into 8 2 times, and the t squared will remain. Minus 4 could go into 4 1 time, and the t will remain, so that leaves the t just like that. And then we add, how many times can 4 go into 12? 4 could go into 12 3 times. So 4 times 3 will give us 12. And at the end of the day, again, remember, if we go to redistribute, so we go 4 here, 4 here, and 4 here, we will end up with what we started with. So 4 times 2t squared is 8t squared. 4 times minus t will give us minus 4t. And 4 times 3 evidently will give us 12. So that's how we could go about proving our answers and our results. So this will bring us to the end, of course, of factorizing by the HCF. I trust that was clear. If not, of course, feel free to contact me. We could always do more. Oh, and by the way, all these questions came from the textbook. I only made up two. Out of the only questions here, I only made up 2. So you have to be very, very careful. And this last one, by the way, it's a these guys one. You have to be mindful of that, because a lot of students would see this and think that they have to factorize using the AC method. But if you try it, you would see that it cannot work, or it would not work, because you would not be able to find any factors for AC. And again, I'm jumping the gun because we didn't do that strategy yet. But you wouldn't be able to find any factors of AC that in turn will give you B. So that's how you know that if you try that one, it wouldn't work. And then you just come back to do the HCF, because notice, common factor, there's a common factor, right? So that will bring us to the end of today's video. And again, as always, like, share, subscribe, share it with somebody, leave any comment section, leave a comment in the comment section below if you have any question. And until then, you take care. Tomorrow, we're going to look at factorizing by grouping.